Hello and welcome back to the Mayhem Lab. In this episode, I've employed Kevin, since he decided to step over, to help me fix up the workspace here.
You got a thing, that's all I know.
All right, so in this episode, what I wanted to do is add a motion sensor to my LEDs. So if you've noticed in a previous video, I had introduced my big rack, my cabinet of things, but you'll notice that it was kind of dark. I noticed that the video itself seemed kind of dark, so I decided I wanted to light it up a little bit. And also I use this workspace back here actually as a workbench. It's where the 3D printer sits, etc. So as you notice, I mounted some LEDs under there. Which is great. It took really no time at all. I don't remember. We'll just go under the letter L for LEDs and pull them up. So these are the LEDs that I used. They are not our traditional, was it WB, the
WS2812B, the
RGB LEDs, the addressable ones. These are just solid white. I chose them for this project because they were sitting around. They're just white. I kind of was thinking about it. I'm like, do I want to put RGB back there? But I didn't really care. I didn't really want to. Actually, I should leave those out. We can experiment. Always put your toys away. All right, so what I got is these LEDs. First off, what's interesting about these, they're 12 volts.
Oh, okay.
Okay. And it's just 2 pins, so you get your positive and your negative. No data. Then, so what I wanted to do is use a motion sensor. So let's show you these guys. So I ended up getting a nice little motion sensor off of Amazon. So this motion sensor allows me to adjust sensitivity and delay. And some other things, but we basically have the 3 pins over there, ground, 5 volts, and then the data pin. Then we're going to use an Arduino to actually run it. So I've chosen an Arduino Nano. I've got a bunch of these laying around. I don't use these all too often. I know we've talked about this in the past, but my main issue with these Nanos is they have stuff on the back side, so they're hard to flush mount to things when we're doing certain projects. So I sort of reserve these for when I don't care. Me also notice that I put the pins on upside down. The pins are poking out what would be considered the top of the Arduino versus the bottom. I did that for a reason. What I'm planning on doing is pulling a trick from Kevin's book and basically just hot gluing this right to the shelf, because
Nice.
it's a workshop. I don't really care. I just want them to come on, right? I mean, I'm not going to put them in a project box or anything. To do that, we need one of these, which is a relay, right? So this can take in the 12 volts and then switch it for when we go ahead and actually get the lights to turn on. Again, 3 pins, just like the other components. And another component we need is the voltage regulator. So this will allow me to take in the 12 volts and output to 5 volts, so I can actually run the Arduino off the same switch. So that way I don't have to do another USB wall wart kind of thing, because that's annoying. So that's it. So we've got basically those 4 components. We've got some wires and LEDs and a power supply.
Cool.
So that's what we're gonna make.
Sounds like fun.
Cool. So let's do that. So what I was thinking, first step, I know we've looked at Arduino in the past, or not Arduino, Fritzing in the past. So I wanted to play a little bit with Fritzing and sort of walk through how to do this.
The schematic?
Yeah, because one of the things that I struggled with when I started getting into a lot of the basic electronic stuff is that barrier to entry, finding decent tutorials and figuring out how to actually just get started with something simple. So I thought that was the whole point. That would be fun. If you're not familiar with Fritzing, I would highly recommend go looking it up. It's a great tool to to visualize you can breadboard stuff out. Basically, you can just plop components on here and try stuff. You can build full-on schematics and also PCB design, which we'll do in later videos. So for this one, let's get started. Over on the right-hand side, we just do some searching. Click on search, it indexes everything. So what did I say? I've got a Nano here. So look up Nano. There's my, whoops, that's not the Nano I wanted. I want version 3. There it is. I need some LEDs. I've already previously looked. Arduino does not have the actual LEDs that I'm using. They do have the RGB LEDs, but what I was thinking, you can yell at me if I'm wrong, but I was just gonna kind of represent the LEDs, because it's not, since we're not actually making a legit schematic and we're not actually making a PCB or anything, doesn't really matter. Let's see, what else did we have here? The keys relay. Need one of those. You know, I think it's also worth mentioning that if you don't have all the parts that you need inside of the Fritzing software, you can most likely can go and Google these and find them. So I actually had to find a couple of these.
Oh, like this part right here, you had to go download the part for?
Yeah, I went and got it. There, and then we need the 96. So here's my voltage regulator.
Nice.
It's that guy, and do a battery representation. And don't yell at me. I know I'm doing this wrong. I'm just going to grab a battery pack to represent my 12-volt power supply. I understand that's not actually 12 volts.
Works for me.
But you get the point. We're going to get rid of the breadboard. We don't actually need it. I'm going to rotate some of these things so they're in, whoops, nice orientation. And there we go. So in, out. Okay, so here's kind of what I was thinking. And of course, stop me if I do anything stupid. So we've got the 12-volt power supply over here. We've got the negative lead that goes to the in. Why do these both look positive? See that? That's interesting.
You're right. Someone screwed up on building that board.
Yeah. So
on the board itself, though, it's
on the board itself, it is actually labeled correctly. So you can disregard this schematic. That should be at negative.
Yeah,
signs.
bottom one.
Because usually they're in line, so negative would be on the side of negative. So okay, we'll just ignore that. And then we've got our positive plop. I think I got that connected, didn't I? Whoops. Nope. Why aren't these connecting?
Try connecting it the other direction, like. Oh,
well, that was no good.
That's something I've seen with Fritzing before. It sometimes has a hard time. See, that one worked because you started at the other end, which I don't know.
Hey,
and there it crashed.
And then it crashed. Okay.
That's another problem you can have with Fritzing.
All right.
Save often.
You're right. I did not save yet. We are going to try that again. I will cheat because I have some of these already downloaded in my parts. So I think this is the one I downloaded, so it's correct.
Oh yeah.
The other one I think was oh, and this is the, nope, that's not the LED I was using. It's a battery supply. There. What's this? That's a Bluetooth module, not an Arduino. Alright, there's our Arduino. Get this back. Get this back. Get that. Then what was the sensor? It was the HCSR 501. There's that. Cool. LED. Whoops, that is not how to spell LED. All right, so let's throw a couple of these on there. And like Kevin said, let's go ahead and save this. All right, so let's try this again. We're going to take our battery and we're going to hook it up to our voltage inverter, not inverter, regulator. Right? Voltage regulator.
Yep.
Be accurate. That. All right. So one thing that you might notice, all the lines come out to be the same color, but what we can do is right-click colored wire, or wire color rather, and then choose whatever color we want, which is a nice way to keep things in order. All right, so this thing would be taking in our 12 volts, and we're going to output 5 volts into the Arduino. So that will be positive to the VIN. You know what VIN stands for?
Voltage in, I think.
Voltage in. That was my guess. I was just curious if you actually knew.
Yeah.
Ground goes there, so negative to ground. Potatoes, potatoes. And now Kevin and I don't know, we're old. I'm not sure what the deal is, but we do like to make square lines.
Yes.
I don't know why. It's fun. So let's do that. Oh dear, the wheels have fallen off. Come on. Okay, go ahead and click save. So there we go. Now we have the Arduino powered through the voltage regulator down to 5 volts. That's neat. So now what we want to do is hook up our sensor, right? So what we can do in Fritzing, you can hover over the pins of the item, and generally they tell you what they are. I don't know if this is the case for every component, but the ones that I've worked with or that I'm used to.
Yeah, if somebody's done a nice job designing it, it should.
Yeah, so we got ground here on the end, so we'll throw that there. Of course.
Now, did you look for like a Arduino sample code or library for this part?
Yeah, I've already actually, not on this Arduino, but I threw it on one of them,
Okay.
and I was playing with it.
Okay.
Just
because usually I
LED.
go there to figure out what pin does the sample code use.
I don't remember.
Oh, okay. Because some of them require a certain pin. This one might be able
so.
to use any.
VCC, so that's power. So 5 volts from the Arduino. That's going to be outbound voltage. Change that to red. And then, yeah, that's a good point. I don't know if it actually matters, but we'll find out, I guess. So, here's something I was thinking about the other day. I instinctively like to make my data wires green. Why do we do that?
I don't know. I like to make them orange.
No, that's fair. So we're just weird, all right? So there we go. So now we have our sensor basically connected to our Arduino, right? So power in, the sensor's actually getting power through the Arduino, and we have got the data connected. Simple. Now we need to hook up our LEDs. In your opinion, what's the best thing to switch, the positive or negative?
I would switch the positive. I would put the ground to the common.
I would agree with you.
Then you just put it to the wrong one.
Huh? Well, no, I'm going to hook the negative up to the LEDs, and then we're going to switch the power. Because this switches 1/2 the circuit.
Oh, okay, you're right. Never mind.
Right?
Yeah. Now I understand what you're asking. You were correct.
So we want the relay to handle the positive side.
Yeah. What are you actually using for the like a 12-volt DC adapter?
AC/DC adapter. Yep.
Okay.
Yep. So yeah, this from these lines forward will all
Should
be
be
DC.
regulated 12-volt.
Be all regulated. Yep. Exactly.
Okay.
And then this would just go. Whoa, Nelly. Yeah, let's try it from the other way. There's common. So then the LEDs are constantly hooked up to the negative ground. Yep.
That makes sense.
And then where did that kick in?
And there you're hooking it to the normally open, which means when everything's powered off, the circuit is open. No current flows through the LEDs.
Right.
If you did it to normally closed, then you'd have to kind of power the relay all the time when you want the LEDs off, which is a weird thing to do. So.
Right. No, that's a good point. Right. So they power in each direction, and of course all the LEDs would be interconnected.
Yeah.
Through the strip.
You connect to the first one, and
right.
they're all. Yep.
So more symbolic
yep.
Than anything. All right. So now we just need to hook our relay up. So again, ground to ground. And then we've got power, 5 volts. So there's my 5 volts. Starts to get kind of messy.
Actually, if you go and drag that black wire up, like
this one?
No, the one that goes into your sensor.
This one?
Yeah, like bring that one up. It'll look really nice.
That.
Now you can do what you wanted to do, and it'll look really nice.
Aw, look at that. Kevin watching out for me. Alright, so now we need signal pin. We'll just go with D3 cuz. And I don't know, this would get routed somewhere. Something like that. That doesn't look too messy. Alright, so there is the basic circuit, right?
Alright, so I have two kind of electrical design considerations that we should think about.
Shoot.
The first one is I think the VN on the Arduino Nano expects 5 volts or something more, and then goes through a voltage regulator that might drop that down to 5 volts.
Are you thinking the Nano doesn't need the...
Well, it does. You can't well, you don't want to feed it 12 volt. It would heat up.
That's what I thought.
But you might want to send it more than 5 volts.
Oh, okay.
It might be worth seeing. We could look at the Nano data sheet to understand what do we want to feed it.
Okay, that's fair.
The next question or the next thought is that relay. So the way this relay switch works is it's a physical switch with a physical magnetic coil inside there. That coil probably draws a bit more power than most things you might drive. I don't know. I don't know how much power it expects, and I don't know if the 5-volt output pin on the Arduino is rated for that.
Okay, we can try it.
Yeah, we can try it. If you're
remember, was it Gurkon 2016? I made that door, that RFID door.
Mm-hmm.
This is what
Same
I used.
Circuit. Okay.
The relay. No, I did use an Uno,
okay.
which the specs were probably different as far as output voltage goes.
Yep.
But yeah, no, that's definitely something.
Yeah, I think
I
think it'll probably work. But yeah, if we to do this design officially, we'd probably want to look at the input power requirements of that relay and look at the output power capability of the 5-volt pin on the Nano, and just make sure that they're in spec. I think it'll work fine. But if you start to see that the relay's floppy, that could be the problem. It's not getting enough power through the Arduino because the voltage regulator there is
it's knocking it down.
Yeah.
So then maybe I would power it right off the.
You could power it off
With
the
the voltage
if
regulator.
that voltage regulator was outputting exactly 5 volts, but we just talked about upping that to
Right.
more than 5 volts potentially.
Yeah, I guess we would see what this thing can handle.
Yeah, maybe while you're wiring stuff up, I'll just go Google like the Arduino and see what it actually expects on the VN pin.
Okay. Cool. So basically, what we're going to do now is wire it all up so we can take some sample code and drop it on here. So let's plug in some wires. So we're back. What we were doing is hooked up the Arduino, made a very large mess on the workbench, which is always fun. Let's see what we got here. So we've got the, whoops, what happened? Where did my camera go? There we go. We got a Arduino hooked up. Got the, decided just to use header pins since everything already had headers on it. So we've got those hooked up accordingly. We've got, let's see if I can just move this camera. Why does it keep cutting out? All right, so there's our relay. Got that hooked up. We've got power supply. Sorry, lighting's kind of a mess here. Power supply. We've got our sensor and the voltage regulator, which is going to feed into the Arduino, which we just got done testing at 5 volts. Or no, we put it at 6 volts. Because that's what the Arduino wants. As
Yeah,
far
the
as
VN pin on the Arduino wants 6 volts, or we could have set the voltage regulator 5 volts and just connected directly to the 5 volt pin. But
So the other thing we did is I went out and got some sample code, and I could put a link in the description. Basically, it's just this this site here. Have a good example of the Arduino code for the motion sensor. You just pop open the serial interface, and we got some motion, and then after a few seconds of no motion, it gets turned off. So we can prove that it works. Right now, it's just doing obviously serial out, which is kind of no good for us. So we're going to change that. We called this pin 3, right? Whoops. Pin 3. All right, so what else do we need to change? We've got our pin for our sensor, and we're just recycling this code, so I'm not taking the time to really rewrite it. We could make it nicer, but the output pin is for the LED. But what we want to happen, instead of doing motion detected, we want to go digital right, whoops, right LED pin.
well, they're doing that in like
What,
4 lines up, aren't they?
They are. Never mind.
Yeah.
So yeah, actually I don't have to do anything,
Yeah.
realistically, right? Because they're already setting the pin to high because they're turning on the LED.
Yeah.
So that should turn the sensor, the relay switch to high.
I think so.
All right, well, let's just try to upload it and see what breaks. Let's turn on the camera. Oh, look at that.
There it went.
We detected motion. Let's see, I don't know if this is going to
Now
work
we
out
sit
there.
real still, and there it goes off. Okay.
So let's see if I can get this. I'm going to work on my camera work. Maybe that's one of these.
You want me to hold the? Oh, there we go. Detect
Yeah,
motion.
here, you do camera work. So let's see if we can. Still very still. All right, no motion. Motion. I think it's. I don't have it sensitive. There we
Yeah,
go.
there's little adjustment things on the side of it, so it's going to need some tuning apparently, but
Yep. But the concept works.
seems to.
Nice. So now the next big step is installing it.
Yep.
So now we just need to do the installation and actually get it to work on the shelf. So I think that we can recap that in a later video. But yeah, so Excellent. Thanks
Cool,
for your
motion
help.
sensor. Do you know how this? So is this doing like? How does this motion sensor work? What is it looking for? Since it's only like one, is it looking just measuring IR light going in and the change in it?
That is a really good question. I do not know. I'm going to go with no.
Okay.
Because I can cover it up.
Oh, and it's still kind of seeing.
No, it's not.
It looks like it's a dome, like an array of LEDs.
Well, no.
I guess, or not LEDs.
You could actually take it apart here.
Oh.
And
Oh, it's just that.
it's just a little sensor. Let me show you this.
Okay.
So that's all it is.
Huh. Yeah, because there's a number of ways you can sense motion. It can be like an echo type thing, or I imagine this is an IR type.
Yeah, I don't know. It's a good question.
Very cool.
So yeah, I guess that's another. I guess that's the fun
yeah,
part. Right?
I suppose that's going to be the same thing that you'd find in like a light fixture outside.
Yeah. In fact, and I don't know if I mentioned this, but that's actually one of the reasons I want to do this, is because the other lights that we have here in the lab, they're all motion sensors. So when I walk into the lab, all the lights come on, and then I don't have to do anything.
Yeah.
So thought it would just be kind of nice to have the bench LEDs the same way as all the other lights on the circuit. So
Sweet.
cool. Well, thank you. So yeah, we'll get this hooked up, and maybe we'll do a guide or something on how to hook it up. It's not hard. It's not revolutionary. This is not new technology. It's just kind of throwing some bits together, and thought it would be fun. So
Yeah, neat.
there we go. Thanks for watching.